So you know what? I did want to talk actually about scientific notation. Let's get into it. Hi, I'm Sarah. I like to make math engaging and fun. Anything specific, any questions you have, send me an email, click the link and do the stuff. So scientific notation is a way of writing really, really big or really, really, really small numbers. Like we're talking about like billions, trillions, quadrillions. So the way that you do this is you write it where you have the first part and then you're multiplying it by a power of 10 to kind of talk about like moving the decimal, right? To talk about like what degree of 10 this number actually is. So if we've got something like 45, there's thousand, million, billion. Let's just talk about 45 billion. The way that scientific notation is written is you've got your first part of the number, which is going to be all like the non-zero numbers. So in this original number, the decimal goes right here, right? It's 45 trillion, billion? Thousand, million, billion. Yeah, been a long day. So the decimal would be here, but what we're gonna do is instead of having to write out all of these zeros, we're going to put the decimal between the 4 and the 5, okay? So now we've got 4.5, but I can't just write 4.5 because those aren't actually technically the same thing, right? They're not technically the same number. Like 45 billion is not the same thing as 4.5. So we have to account for that changing of the decimals. So the way that we account for that is we say, well, it's 4.5 if you multiplied that 4.5 by 10 to the, here's the fun part. We're going to use an exponent on the 10 to talk about how many spaces we move the decimal. Okay, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 45 billion is the same thing, is equivalent, right, to 4.5 times 10 to the 10th power. So a couple of notes with this. This first number before the times 10 to the whatever, that has to be between 1 and 10 or like 1.9.9, right? So it has to be like, if we were to write this as a inequality, right? So it needs to be greater than or equal to 1.0 and less than 10. So it can't be 10, but it could be 9.999, right? But it can't be 10. Because if it were 10, you would just write it as 1.0. And then this exponent tells you how many spots to move the decimal because it is a power of 10. So in this case, I'm moving it over to the right 10 spaces because this is a positive exponent. The decimal is going to move to the right to make it bigger, right? So it's times 10, times 100, times 1,000, times blah, 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 right? So I'm saying it's 4.5 times 10 to the 10th power. So that's for a really, really big number. Now for a really, really small number, this rule is still always going to apply, right? This is always going to apply. The exponent is what's going to determine or what's going to tell you if it's a really big number or a really small number. So if I were to change this to 0. We'll just keep the 4.5, right? 0.00000000 4, 5. What would happen is I'm still going to look for my non-zero numbers. Boom, 45, okay, or 4 and 5. Boom. I'm going to put the decimal between them, so it's between 1 and 10. And then I'm going to count, okay, if I have 4.5 here, how many times do I need to move the decimal to get back to the original decimal spot? So just like we did with the big number, right? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's still 10 spaces, but the way that we show this is a really tiny number as opposed to a really, really big number is that we do a negative exponent. Negative exponents kind of make it into like a fraction. I'll kind of get into that, right? But the negative exponent means that the negative piece drops it down into the denominator. I mean, I guess I should just explain that now, huh? Might as well. It's a good excuse to. I don't like writing in red, but I might have to. So if I have 2 squared, that equals 4. Great. 2 to the 1 power, that equals 2. 2 to the 0 power, You guys remember what I always say about patterns? The pattern doesn't change. So as this exponent goes down by 1, right? 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 would be -1. -1 minus 1 would be -2, right? So these patterns are never going to change. As the exponent goes down by 1, over here, I'm dividing by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. And 1/2 divided by 2 is 1/4. Now, this is also the same thing as 1 over 2 squared. Okay, so all that the negative does is it just drops it down into the denominator, and then the power still stays there. So like if I had something like x to the -4th power, this is going to be the same thing. That negative, all it's going to do is boop, drop it downstairs. So it's going to go 1 over x to the 4th. That's it. That's mathed up. So with this being 10 to the -10, it's getting littler, right? We're multiplying this by 1 over 10 to the 10th power, which is a very, very, very small fraction, right? Teeny tiny little fraction. So as we're working through this, that's why that negative power is going to make this such a tiny little number. That's mathed up.